Welcome to Veteach. In this video, we'll discuss about mobile agents. What do you mean mobile agent? Why do we require mobile agents? What are the features of mobile agents? We'll discuss here. What is a mobile agent? It's a special program that is autonomous and can move through a heterogeneous network under its own control, migrating from host to host and interacting with other agents. What is the advantage of this mobile agent is it can move accordingly inside the network and it can communicate with other nodes inside the network in an autonomous way. It can execute at any point or suspend its execution, move to another host and continue its execution on the another host. Means, so as we have discussed that this MANET is going to have different type of protocols like Zigbee, 802.11, Bluetooth and different communication mechanisms. By using this mobile agent, what we can do is we can ask this mobile agent to sit on our system and perform a task and then move to another system and then work on that host. It can move from one host to another host and do a work and then suspend a work also. Mobile agents have certain features such as autonomy, mobility, goal-driven, temporal, continuous, intelligence, cooperation, learning, reactivity, etc. Means these are all the different features that a mobile agent is going to perform. Due to these features, they are well adapted to the domain of mobile computing. So due to the features of all these features, they can be very much useful in our mobile computing environment. For instance, a mobile agent can move from PDA to internet to collect interested information to the user. For example, if I am working on a personal desktop assistant, so you have requested some data from the internet. So what this mobile agent is going to do is, on behalf of you, from PDA, it's going to shift to the internet and get the data that is required for you. And then from the internet, it is going to switch again to your PDA and display the required information by the user. In this way, a mobile agent can be moved from one host to another host to perform an action. What are the advantages of mobile agents? Reduction of network traffic. So due to generally what happens is there is a lot of network traffic involved inside the network. There will be a lot of messages that will be exchanged between one node to another node inside the network. But when we use these mobile agents, automatically what happens is there is a chance of reduction of traffic present in the network. Overcome network latency. The delay between the nodes exchanges can be reduced when we use these mobile agents. Encapsulation of protocols. As we have discussed that there are different type of devices that will be using different type of protocols inside a MANET. When we use this mobile agent, it can encapsulate one protocol with another protocol, or it can establish a communication between two devices which works with different protocols. Asynchronous and autonomous execution. It is going to work asynchronously with unless autonomous execution. Dynamic adoption, which can adapt to any dynamic network changes. Seamless system integration. It can communicate seamlessly to the system to transfer the data. Robust and fault tolerant. So it can update automatically without any problems and it can resist to faults if there are any. What are the applications of mobile agents? E-commerce. E-commerce is the place where these mobile agents are being used to transfer the data between one site to another site if there is any. Personal assistance. For personal assistance purpose also we can use these mobile agents. Distributed information retrieval. If the information that is required for the user is at different systems, if it is distributed at different systems, this mobile agent on behalf of the user can get the data from different distributed systems, which is known as distributed information retrieval. Telecommunication network services. In telecommunication network services also there will be mobile agents in order to communicate between two different network devices. Monitoring and notification. Whenever something has to be monitored and notified to the end user where a person cannot be present, these mobile agents will be very much suitable for this. Parallel processing, which can perform the operations parallelly without any problems. Next one is service discovery. What do you mean by service discovery? Service discovery is a special protocol that was introduced by Bluetooth in order to know what are the different type of services that are available in the proximity, means in the nearest range what are the different type of services that are available. In order to know that, this protocol was introduced by Bluetooth. SDP, what it is going to do is, it's going to define only the discovery of services. Discovered services can be cached and gradually discovery is possible. Whatever the services that were discovered, they will be saved into the cache memory, and all the next nearest discoveries can be done. All the information on the SDP server have about a service contained in the service record. So after getting a service discovery, that is going to store it on the SDP server by using a service record. This consists of list of service attributes and is defined by 32-bit service record handle. It's going to work with 32-bit services, and all the services will be stored inside the service record on the SDP server. A service attribute consists of an attribute ID and an attribute value, means each and every service that was identified will be given an ID with a unique identifier number and the attribute value which tells what is the service name which is present inside the service record. And then the 16-bit attribute ID distinguishes each service attribute from other service attributes within a service record. Within a service record, it's going to have all the list of services. Since this service ID is a unique number, a 16-bit unique ID number will be allotted to each and every service in order to differentiate with other services present in the service record. This attribute ID also defines the semantics of the associated attribute value. And then this attribute value can be an integer, a universally unique identifier, a string, a boolean, or a uniform resource locator. Means it can be of any type. This ID value can be any value. This is about service discovery. Next one is wireless application protocol, WAP. What is this wireless application protocol is? It's a global standard and it is not controlled by any single company. This WAP is a forum that is formed by a number of companies and they are being maintained by all these companies. What are those companies? Are Ericsson, Nokia, Motorola, and Unwired Planet founded this WAP forum in the summer of 1997 with the initial purpose of defining an industry-wide specification for developing applications over wireless communication network. So it was not being owned by a single company, it was formed by a collection of companies with the intention to create applications which works in wireless environment. For this main intention, this WAP protocol was introduced in 1997. The WAP specification defines set of protocols in the application. It contains the various set of protocols in the application, session for session management, for transaction management, security, and transport layers, which enable operators, manufacturers, and application providers to meet the specifications that are given by the WAP forum. Challenges in advanced wireless service differentiation and fast service creation. So what this WAP forum has done is they have created some set of rules and the services that has to be provided by all the service providers. Everyone has to obey them and they have to functional according to these layered protocols. So if you look at what is the WAP architecture, there are different type of layers like transport layer, security layer, transport layer, transaction layer, session layer, and application layer. In different layers, different protocols are being used. Let's discuss about different protocols that are used at each and every layer. First one is WDP. WDP is a protocol that is used in transport layer for transmitting the data from one device to another device. WAP datagram protocol and additional wireless control message protocol. Wireless control message protocol and WAP datagram protocol. These two are present in the transport layer, which sends and receives the messages via the available barrier network, including SMS, USSD, CSD, CDPID, IS-136 packet data, and GPRS. So in order to send and receive the SMSs or any type of audio or video type of messages, this transport layer protocols, that is WDP and WCMP, will be used for receiving the data by using WAP protocol in the transport layer. The transport layer service access point is the common interface to be used between higher layers of the underlying network. when this transport layer want to communicate with the other layers, it's going to have a transport access point through which it's going to communicate with other layer in the network. WTLS. So in the next higher layer, that is the security layer, this transport layer security protocol is being used. In the security layer that we have discussed here, we are going to use this WTLS. WTLS stands for Wireless Transport Layer Security Protocol, which is going to offer some set of services that are relevant for security purpose. Those are SEC, SAP. What is this WTLS is? It is based on transport layer security like TLS, formerly called as SSL, that is Secure Socket Layers. WTLS has been optimized for use in wireless network with narrowband channels. By the use of these narrowband channels, what happens is it's going to provide high level of security to the data that is being transmitted from one node to another node. It can offer data integrity, privacy, authentication, and denial of service protection. So what this is going to do is it is going to provide security to the data by providing data integrity, confidentiality, authenticity, privacy, and denial of service protection also. If an unauthorized person tries to access the data or sends the data to the source or to the destination, this WTLS protocol is going to avoid them, and it's going to provide a level of security to do all these things. Next one is WTP. What is WTP stands for is WAP Transaction Protocol, which is going to deal with the transactions that is being sent from one device to another device, which is going to provide transaction support. It's going to treat the messages sent from source to destination as a transaction. This WTP is going to work with this transaction management, adding reliability layer to the datagram service provided by WDP transaction SAP. So there is a WDP transaction that we have already discussed in the earlier slide, where the datagram is being sent from source to destination. This transaction protocol is going to add some set of additional functionality to the WDP. Next one, wireless session protocol. Wireless session protocol is going to provide some session management functionality in the session layer. The session layer with the wireless session protocol currently offers two services at the session SAP. One is connection oriented and the one is connectionless if used or directly on the top WDP. Means it's going to provide either connectionless or connection oriented services sessions according to the requirement. A special service for browsing the web. For browsing the web, there is a special service that has been identified in HTTP 1.1 functionality, which has long-lived session state, session suspend and resume. So session suspending and resume can be done. Session migration and other features needed for wireless mobility access to the web can also be done. Some of the special features were added to this session protocol, that is especially for browsing the data, that is WSP/B. The different services are long-lived session state. If I want to make a session to be lived for a long time, or suspend a session and resume it after some set of time, or session migration. If I want to migrate a session from one browser to another browser also, we can do all these functionalities by using this WSP/B. Next, WAE, where it's going to provide the communication with the applications to the end user. The application layer with the wireless application environment offers a framework for integration of different WW and wireless telephony applications. So by using this WAE, what we can do is we can combine different type of services that are offered for WW and mobile application. WAE is the layer through which its WAP is going to communicate with the end user application. This is the different layered architecture of WAP and what are the different protocols that are used in different layers. In application layer we use WAE. In session layer we use WSP. In transaction layer we use wireless transaction protocol. In security layer we use wireless transport layer security, WDP wireless datagram protocol, and then GSM and CDPD are the protocols that are present in the last layers. So in all this entire WAP architecture we make use of WML language, wireless markup language, which we will be discussing in the next videos. In the next video we'll discuss about Bluetooth and what is the layered architecture of Bluetooth. Thank you.